Okay, so now let's briefly discuss the difference among these t-tests and when to use which. So the three t-tests that have been covered in class is the one sample t-test, also known as the single samples t-test, dependent samples t-test, or paired samples t-test, repeated samples t-test. There's a few different names for that one. Then finally the two independent samples t-test. So we want to know when to use each one, what characteristics to look for, and these are all going to be kind of within the word problem, so make sure you read things carefully. So with the single sample t-test, just like the name implies, you have one sample. That is, you've collected data from one source, one group of people. Then you're going to compare the mean or the average of that sample to some known value. So this known value is usually like a national average, 0, or a very well established normalized value. One of the most ideal being the mean IQ being 100. That's very well established and normalized across the US. So it's some known value that you're comparing to. So for a dependent samples t-test, again, you have one sample. However, you collect data from the single sample twice. So the most common application that you're going to see for this is a pre-post test design. So what that means is you take a sample, you measure the sample at time 1, then you measure the same sample of people at time 2, and you compare time 1 and time 2. For example, if I compared the means from exam 1 for your class to the means of exam 2 for your class, that's a dependent samples t-test. So I used a single class, your class, just one sample. Now I'm looking at 2 time points of measurement from that same sample. Okay, now finally the independent samples t-test. This one's going to be the most different in that you're using 2 separate, completely independent samples, or in other words, 2 groups of people. So this is probably the most common test that you see in research. If you pick up a research paper, especially a psychology research paper, at random, there's a high probability you're going to find an independent samples t-test in there. So you'll see it when comparing a group who took a new drug versus a group who took a placebo. That's one example. Or maybe a group who received a new therapy treatment versus a different group who received some control or sham treatment. So you just want to know, is group 1 different from group 2? So keeping with the class example, if I took your class's exam 1 scores and I compared them to a different section from PY216, and I compared them to their exam 1 scores, I'm looking at 2 different groups of people, your class versus the other class, who completed the same measurement, that is, that exam in this example. So a lot of the questions I've been getting seem to be over the estimated standard deviation. So let me see if I can clear this up if I can. It seems to be that the word estimate or estimated appears to be throwing several people off, and I just want to go into why that is. So in a population, we don't need to estimate a thing. That's because we know everything. Again, this is because when we say population, we mean that includes every single individual. Well, guess what? We pretty much never have a population when we're doing research. We have a sample, which is a subset of that population. Because we have the sample, this smaller subset, we have to use them to represent what might be the population's parameters. So if I have a sample, I don't know the standard deviation for the population from whence they came, but I can't estimate it since I have a representative of that population. So how do I do that? I do that by calculation of the sample's standard deviation. So the sample's standard deviation is the estimated population standard deviation. So the bottom line for you, though, is that what you need to know is that don't let the word estimate throw you off. We just have to use that word estimate because we're working with samples when we do statistics. So what this means for you, bottom line, when you're doing the exam, is that when you see estimated standard deviation, you just calculate the standard deviation for the sample. So don't let estimated standard deviation throw you off. If you see estimated standard deviation, calculate a standard deviation for the sample that you have, that group of numbers that you have.